Have you ever wondered how we can measure the thickness of something as fine as a wire or a sheet of paper with extreme accuracy? Well, the answer lies in an incredible instrument, the screw gauge. This device works on a simple mechanical principle, the movement of a screw when it's rotated. With every turn, the screw moves linearly forward or backward along its axis. And this motion allows us to measure very small lengths, even up to the thousandth of a centimeter or beyond. For example, a micrometer screw gauge can measure as small as 1 micron, that's 0.0001 centimeter. Let's now understand what makes up this precision instrument. The U-shaped frame holds all the main components. At one end, we have the stud A, and at the other, the movable screw B. Together, they grip the object to be measured. A ratchet ensures that the pressure applied is uniform, preventing damage to delicate samples. The sleeve, also called the nut, is marked with the main scale. Surrounding it, the thimble or hollow cylinder carries the circular scale, usually with 100 equal divisions. This circular scale rotates over the main scale, and together they help us take the most accurate measurements. Now comes the heart of the concept, pitch and least count. The pitch of a screw is the linear distance it moves along its axis in one complete rotation of the head. For instance, if one rotation moves the screw by 0.5 mm, then pitch equals 0.5 mm. The least count is the smallest value that can be measured using this device. It is given by the formula least count equals pitch divided by number of divisions on the circular scale. So, if the pitch is 0.5 mm and the scale has 500 divisions, then the least count is 0.001 mm. That's 1 micron. But sometimes things aren't perfect. When we close the jaws completely, the zero on the circular scale should align with the baseline on the main scale. If it does, there's no zero error, but if it doesn't, there's a mismatch. This gives rise to zero error, which can be of two types. Positive zero error, when the zero on the circular scale is below the baseline, and negative zero error, when the zero is above the baseline. Let's say the fifth division of the circular scale coincides with the baseline, and our least count is 0.001 centimeter. Then zero error equals 5 into 0.001, which is 0.005 centimeter. To make sure our measurements are accurate, we need to correct them for any zero error. And here's how. Always subtract the zero error with its proper sign from the observed reading. So correct reading equals observed reading minus zero error. If zero error is positive, subtract it. If it's negative, subtract its negative value, which means you're effectively adding it. This correction ensures your final value truly reflects the actual dimension of the object. Let's walk through the steps to use the screw gauge effectively. First, determine the pitch and least count and check for any zero error. Then, place the wire or object gently between the jaws. Rotate the ratchet till it just grips the object. Now, note the main scale reading and then look for the coinciding circular division. Let's call it P. Multiply P by the least count to get the circular scale reading. Finally, total reading equals main scale reading plus circular scale reading, and then subtract the zero error. That gives the true diameter of the object. Repeat this in perpendicular directions to avoid any shape-related errors. Here's a quick example. If the main scale reading is 0.2 centimeter and the 56th circular division coincides with the baseline and least count is 0.001 centimeter, then circular reading is 56 into 0.001, which equals 0.056 centimeter. So, the total observed reading is 0.2 plus 0.056, that's 0.256 centimeter. Now, if there's no zero error, this is your final answer. But there's one more thing to watch for, backlash error. Due to wear and tear, Rotating the screw in opposite directions can sometimes cause a small lag before the screw actually moves. To avoid this, always take the reading by turning the screw in one direction only. It's a small detail, but it can make a big difference.